Hi class, Mrs. Matheson here. Today we're going to start Unit 6, Notes 1, which is on the Pythagorean Theorem and its converse. So our learning target today is to apply the Pythagorean Theorem and its converse to solve problems and logically justify the results. So we've already talked about Pythagorean Theorem, and we've seen that already once this year, and that we see as a squared plus b squared equals c squared. Remember that a and b are the legs of the triangle, and that C is our hypotenuse. All right. Hypotenuse, remember, is the longest side. It also is the one that's directly across from the 90-degree angle. So if we look at our picture here, we see that our hypotenuse is across from that 90-degree angle. Okay, so let's just practice our Pythagorean theorem. Looking at number 1 here, we have 6, 15, and x for side lengths. Our 90-degree angle, the one across from that, is our x. So that's going to be our c squared. Then it doesn't matter the order that we put our 6 and our 15 in, because it's addition. 6 squared gives us 36 plus 15 squared, which is 225, equals our x squared. We're going to add those to get us 261 and x squared. And then remember that we take the square root on both sides. And so let's just round these to decimal places. Let's just round it to 1 decimal place. So we get 16.2 for our missing side. Okay, so let's take a look at number 2. Again, we see that across from number 2 is our x. So we're going to set that as our c squared term. We have our 17 squared plus 7 squared. We get 289 plus 49 equals x squared. So we have 338 equals x squared. And I want you to find me x for this problem. And make sure you come with that done for tomorrow or the next day. And then we have 3. Problem 3, we see our 90-degree angle is here. And across from it is our 11. So that makes our 11 our c term. Again, it doesn't matter which order we put our x and our 9. Okay, so I've got it set up for you. You guys can go ahead and finish that for this problem. So you may have talked about Pythagorean triples or heard of those before. Pythagorean triples are 3 numbers that will always give you a right angle, or a right triangle, no matter what. So 3, 4, and 5 is the most common Pythagorean triple. Then we also have 5, 12, and 13, and then 7, 24, and 25. So if we did this in our Pythagorean theorem, just to double check it, let's do our first one, 3, 4, 5. 5 is going to be our hypotenuse because it's the longest side. So we would have 3 squared plus 4 squared equals 5 squared. 3 squared gives us 9. 4 squared gives us 16. And 5 squared gives us 25. And we see 25 equals 25. So we know that this is a Pythagorean triple. Just trust me that the other two work. All right. So sometimes we can find other common Pythagorean triples by taking our first ones, and we're going to take this and we're going to multiply it by 2. So we have 6, 8, and 10 as another Pythagorean triple. And that works for all of the original ones. If we times it by 2, we get 10, 24, and 26. And then we're going to multiply this one by 2 also. So we have 14, 48, and 50. All of these are going to be Pythagorean triples. We can have the same idea and take our original Pythagorean triple and times it by 3. And now we have a new one. 9, 12, and 15. If we times our original one by 3, now we have 15, 36, and 39. And then take our original, times it by 3, 21, 72, and 75. These are all Pythagorean triples for us. So we can say, we can take our original Pythagorean triple and times it by any number, such as x, and it will give us another Pythagorean triple. So if you ever see something that's multiple of 3, multiple of 4, multiple of 5, hey, that's a Pythagorean triple. Same idea here, 5x, 12x, and 13x, or 7x, 24x, and 25x. Those are all going to get us different Pythagorean triples. Okay, so we also talked about that the converse of the Pythagorean theorem is what we're going to be learning about in our notes today. So the converse says, if you know that a squared plus b squared equals c squared, then your triangle is a right triangle. Okay, so think back. Originally, a Pythagorean theorem, we said, hey, it's a right triangle, so it's going to work with Pythagorean theorem with a squared plus b squared equals c squared. Now we're saying it works for a squared plus b squared equals c squared. Therefore, this triangle is a right triangle. Okay, we also have some inequalities here. It says if c squared is less than a squared plus b squared, then triangle ABC is an acute triangle. So if your c squared is smaller, then it's going to give you an acute triangle. We also have if c squared is greater than a squared plus b squared, then this triangle is going to be an obtuse triangle. So just keep in mind, if c is big, then you're going to have an obtuse triangle. Okay, so let's try this out in this next problem. It says determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. So before we did this, we said, hey, is it a triangle? Hey, is it a right triangle? Now we're going to say, is it a triangle? What kind of triangle is it? So let's go ahead and check out our first one. So let's see here. 16 is definitely our C because it's the biggest. So we're going to do 7 squared plus 14 squared and see if that is going to be, greater than. We should try this again. Remember, to be a triangle, you need to add your two small sides and see if it's greater than your large side. 7 plus 14 gives us 21, which is greater than 16. So yes, this is a triangle. Now let's see what kind of triangle it is. Now we're going to throw in the squared. 7 squared plus 14 squared. And we want to know, is it equal to, is it greater than, or is it less than 16 squared? 7 squared gives us 49. 14 squared gives us 196. And 16 squared gives us 256. So let's combine our terms to get 245. And we have 256. 245 is less than C. So C is big. C is bigger than our two sides together. So this is an obtuse triangle. Okay, remember C was big. Let's go ahead and try with B. Let's make sure B is a triangle first. So our C term is our 41. We want to know, is 9 plus 40 greater than 41? Yeah, 49 is greater than 41. So this is a triangle. Now we're going to find out what type of triangle it is. So we're going to take our two legs and square them. And we're going to see, is it greater than, is it less than, or is it equal to our 41 squared? So 9 squared gives us our 81. 40 gives us 200. And, 1600, sorry. And 41 gives us 1681. If we combine our terms, we get 1681 equals 1681. So this is going to be a right triangle. Okay, so I want you guys to try C. First, you're going to determine, is it even a triangle? And then you're going to determine, well, if it is a triangle, what type of triangle do we have here? All right, we have 6 and 7 left here. So 6 says find x. Well, we're going to use Pythagorean theorem to do this. And I'm just going to get it started for us, and then we'll continue the discussion about it in class. So across from our right angle is x. So that is our C term. We're going to square both sides. So we have 8 squared plus x minus 5 squared. We need to solve for x. So I want you guys to give this one a try and be ready to discuss it when you guys come back to class. Don't forget to go on and take your Schoology quiz. We'll see you guys then.